Derivative of sine. As always, let's start with our first principles. So the limit as h approaches 0 of sine x plus h minus sine x over h. So I did say that in the main video, that this is definitely one that specialist students should watch. If you're not a specialist student and you're watching this, that's absolutely fine. But there is one identity that I'm going to be using, and it's this angle sum. I think you guys are familiar with it from Spec, but if you don't do specialist, then obviously you won't have seen this before. But this is our angle sum formula. There's one for cos as well. So if you want to go off and try and prove the derivative of cosine, use that one. I would love to see your proof. Okay, limit as h approaches 0 of sine x plus h. I'm going to use this. Yeah, so sine x cos h plus cos x sine h. Cos h, not hyperbolic cos. And then minus sine x all divided by h. I'm going to go through and split up this fraction. I'm just going to take out a factor of sine. So what will be left is cos h minus sine, minus 1, sorry. And then in my other fraction, and this is a limit of all of this, yeah? In the other fraction, what's left is just this is left. So cos x sine h over h. Now I'm going to split this up into two limits, and at the same time, I'm going to get rid of all this stuff that don't belong inside the limit. So remember, anything that doesn't have a h in it, whatever the limit is talking about, right? We can take out of the limit because whatever h does, whatever happens to h, sine x is not affected, right? So I'm going to take out a sine x, and I'm going to say this is the limit as h approaches 0 of the rest of this stuff, cos h minus 1 over h. And then in this other limit here, I'm going to take out the cos x. Limit as h approaches 0, sine h on h. Again, I'm going to sort of fudge this because we don't know heaps about limits. We don't learn a lot about limits and methods. But I'm just going to sketch this function, cos h minus 1 on h, or I'm going to change it to x for Desmos. So there's this function here. It looks a little bit funny. It looks really cool, actually. But as x approaches 0, or h approaches 0, y is also approaching 0. Okay, so same deal. This is going to equal, sorry, not 1, but 0. Okay, same deal over here. I'm going to sketch sine x over x. Graph that, and we're going to look at what happens as x approaches 0, y approaches 1. So I'm going to say this is equal to 1. Okay, and now I'm sure you can see what's going on here. This is sine x times 0, so that's 0. And this over here is cos x times 1, so we get cos x.